Hello Sudoku friends and welcome to a Diabolical puzzle today. I grabbed this off of a website that offers a number of difficult puzzles because frankly I wanted to see how far I can get without using pencil marks. I'm pretty sure that I will use pencil marks for this puzzle, even though there are as many as 30 givens in this grid. Um, but I will start without using pencil marks and I'll see how far I can get. And if I need to use some pencil marks, I will show you how I use pencil marks myself. So without further ado, let's see how far we can get. As usual, I will talk a little while I familiarize myself with the grid. I can see a 1-8 here and a 1-8 here, so a 1 and an 8 will have to go in one of these, or rather in two of these three cells up here. And there's a 5 here and here, so one of these two will have to be a 5. Well, we can find a digit, we can find an 8. There's an 8 here and there's an 8 here. And there's an 8 down here in the bottom row, so this cell here must be an 8. And the 5 here and this 5 puts a 5 in this cell, doesn't it? We need a 2, 3, and a 6 for these three cells, and there's a 3 here and there's a 3 down here, so this cell will have to be a 3, and now we just need a 2 and a 6 for these two cells. And simple logic dictates a 9 for this cell because that's the only cell in this row that can be a 9 because of the 9 down here, right? So the 9 here and the last digit will have to be a 1. And the 9 here and here fixes the 9 for this cell in row 4. And we can find a 6 for this bottom's row. There's a 6 here and here, and therefore this cell must be a 6. We can find an 8 because of this 8 here and the 8 here and this 8. An 8 must go in this cell in row 4. Because of this 1 here, we know that a 1 for column 9 will have to go in one of these two cells. So we still need to find a 1 for these three cells, or more correctly, for column 8. And there are these two ones here, and that tells us that the 1 will have to go here. And one of these two cells now will have to be an 8, as we discussed earlier, because of the 8 here and the 8 here. And a little bit of a counting exercise here. For column 7, we still need to find 3, 4, 6, 8, and a 9. Let's look at this cell here. It can be seen by a 3, 6, 8, and a 9, and therefore it must be a 4. This 4 and this 4 and the 4 up here gives us a 4 for column 9. And also a 4 now for column 3 because of the 4 here. We need to find a 3 for this column 2, and since it can't go here, it must go in one of these three cells, and it can only go in this one because of these two 3s. And then now we also know that a 5 will have to go in one of these two cells because a 5 can't go here due to the 5 up here. So one of these will have to be a 5. And given the 5 here, we now know that this cell will have to be a 5 in this row and in this column. again because of the 5 up here. And because we found the 4 here, we can now place a 4 in this cell. We got the 4 here and here as well. So the limitation for this block of 3 by 3 cells for a 4 is right here. Now we just need a 2 and a 7 for this cell, and we need a 2 or a 7 for this cell, a 2 or a 7 for this, a 2 and a 6 for these two cells. And by the way, also a 2 or a 7 for this cell. At this point, I am tempted to try to input some pencil marks, and I will begin by demonstrating the Snyder notation. The Snyder notation says that if a number or a digit can go into a row or a column or a 3 by 3 block exactly twice, then we can enter it. So as an example, we know that for this cell here, we can enter a 2, and for this, we can also enter a 2. We can, by the way, also enter a 7, 2 and a 7. And for this cell, we can enter a 2, and we can enter a 2 here as well. And because there are only 2 cells left to be filled in this block, we know that the other digit will have to be a 6. And we also know that these 2 cells can take a 3. So we can enter a 3 here and we can enter a 3 here, but not here because there is already a 3 in this column. But let's start with the ones. This was just an explanation. The 1 here and the 1 here forms a 1 in this cell or in this cell. And because of the 1 here and here, 1 will have to go in this cell or in this cell in this column. And we have a 1 here and a 1 here. And that means that a 1 will have to go either here or here in row 4. And as far as I can see, this is as far as we get with the 1s. Now let's move on to the 2s. In this block, a 2 can go exactly here or here, but not here because of the 2 that we have here. And I think that's all we can do for the 2s. Now on to the 3s. 3 here, 3, we got the 2 3s here, and now we need, well, we can't place any more 3s because in no row, column, or 3 by 3 block can a 3 go only twice. Now on to the 4s. I actually think we got all the 4s in the grid, so that was easy. Now on to the 5s then. The 5 here and here puts a 5 in this cell or in this cell. And we have a 5 up here and a 5 here, and that gives us a 5 for either this cell or this cell. And this 5 gives us the option of placing a 5 in this cell or in this cell, doesn't it? And I think that's about it for the 5s. On to the 6s. Let's see. There aren't really any more places that we can place a 6, I think. 6 nodes, except for what we already did here. The 7s, this 7 and this 7 puts a 7 in either this cell or in this cell. And we already got the 2 7s for these 2 empty cells. And I think that's it for the 7s. How about the 8? The 8 here and here gives us an 8 for this cell and possibly for this cell. And also for this cell and this cell because of this 8 here and here. The nines. The 9 here and here gives us a possibility for a 9 here and here. And because of this 9 and these two 9s, we can put a 9 in this cell or we can place it in this cell. And I think that's it for the 9s. So presumably this is when it should become much clearer how to get on with the puzzle. And in truth, for this puzzle, it just doesn't appear to me. So my next step is usually to enter into cells by values. That means cells that can take exactly two, not three, but two different values. I will enter those. This may appear as more clutter in the puzzle, but it often helps me to get on with the puzzle. And actually, for this cell up here, we can easily input a 2 and a 7 because we have a 2 and a 7 here, and there is only this other empty cell in the column. So a 2 and a 7 here would make perfect sense. I would also enter a 6 as an additional digit here because these three cells can take a 1, 6, and an 8, but the 8 can't go here. So there can only be two choices for this cell. So I will input a 6 here. And opponents of this strategy will say that this makes it more difficult to view the puzzle at a glance and to find a solution. And I will agree with those. But sometimes you need to do more when you can't get on with just the Snyder notation. And rather than filling all the squares with all possible values, uh, I think this is a better solution. At least it works for me. So these three empty cells can take a 1, 2, and a 7, right? The 7 here gives us a 7 for this cell or for this cell. So now we have a 2, 7 here and here and here and here. And sometimes this pattern can open up for a way to continue with the puzzle. I can already see that we have a 2 here and 2 here, and we have a 2 here. And we also have a 7 here and a 7. So we actually have a 2, 6, and a 7 in sort of a bent triple. And I will keep an eye on that and to see if that will help me as I fill in a few more digits. And while I think about that a little, I will also input a 6 here because this cell can only take a 6 or an 8 because of the 1 here, right? Since I have an eye on the triple here, the bent triple, I want to input some more 6s, and there can be a 6 in this cell, and there can also be a 6 in this cell. I know that there can also be a 2, so let's just input the 2 as well as a precaution. So we can now have a 2, 6, and a 7, but we know that one of these will have to be a 7. Let me input a few more pencil marks. We need a 1, 2, and a 5 to complete row 9. There's a 2 here, so this has got to be a 1 or a 5. Just strikes me that, of course, we can't have a 6 here as a pencil mark because we have a 6 already in the row. So since these two cells have to be 2 and 7, that's a remote pair. And we have a 2 here and we have a 2 here as the only values. Then we can remove this 2 here as a candidate because we have an X-wing on 2s. Now here is a very important chain, and we can actually solve this chain without inputting even more pencil marks. I have been looking at the by-value cells here: 27, 26, 16, 27, 17, and the 27. Let's try to follow this path and say what happens if this is a 7. Clearly, this cell cannot be a 7. Now, what happens if it's not a 7? It's a 2. If it's a 2, then this cell is a 6, right? So if this is a 6, then this cell cannot be a 6. It therefore must be a 1. If this cell is a 1, then clearly this cell cannot be a 1. It must be a 7. And again, this cell cannot be a 7. So either way, if this is a 2 or a 7, this cell cannot be a 7. Therefore, it must be a 2, like so. And now we can remove the 2 candidate from this cell, and it becomes a 1. And this cell now becomes a 7. And now we know that this cell must be a 7 because there is a 7 already that can see these 2 cells. And this 7 takes care of this 7, and now this is a 2, and this is a 7. This is now a 2, therefore this must be a 6, and this must be a 2. And of course, the 7 here now prevents the 7 from going in this cell. It must go in this cell. And now we have a perfect column, 1 through 9, all based on a chain. So my advice is every time you see by-value cells that form both an X-wing and a chain, try to follow the chain and see what comes up. I'm sure this has a fancy name like an XY, XYZ wing or something like that. I don't really care about names. I care about solving puzzles. So let's continue with the puzzle. I can see the 7 here and here force a 7 in one of these 2 cells. And the 7 here and the 7 here force a 7 in one of these 2 cells. We still need to find a 7 for this column. Since it can't go here, here, or here, it must go here. And therefore, this cell now becomes a 1. Sorry, my mistake. This is a 7, of course, and this is a 1. Now we have a 1 here, and we have a 1 here, and we have a 1 down here. So this cell becomes a 1. And therefore, this cell cannot be a 1. It must be a 5 or a 2. And since there's a 2 already in this column, this is a 5, and this cell must be a 2. The 2 here and the 2 here and the 2 here gives us this 2. And you can see how quickly we went from not really knowing what to do to almost completing the puzzle. Now, the 2 and the 3 here have now found their resolution. The 3 goes here and the 2 goes here. We still need a digit for row 6, and the missing digit, of course, is a 3. Now, this cell becomes a 3 because of this 3 and this 3 and the 1 up here in the top row. And therefore, this cannot be a 9. It must be a 3. What else can we see? We need to find a 5 for one of these 2 cells. We have a 5 down here, so the 5 goes here, and this cell a 9. Now we just need to find a 6 and a 7 for these two cells. There's a 7 already in this row here, so clearly the 6 goes here and the 7 here. The 7 here and here and here gives us the 7 for this column. And now we just need to find a 9, and it goes here, of course, because of the 9 here. The last digit is going to be a 6. And that takes care of the 6 we have here. And now we need a 1 and an 8 to complete this box. There's a 1 already in the column, so of course the 8 goes here and the 1 goes here. And now we know that this cell must be an 8, and the last cell up here has got to be a 6. And the 9 will have to go here. The 6 for one of these two cells, and there's a 6 here. So this is a 6, and the last digit in the puzzle is a 5. I hope that you enjoyed this little demonstration of how I personally do pencil marks. I stop with the pencil marks as soon as I can move on with the puzzle. My preference is to not use pencil mark at all, but sometimes it's just not possible, at least not for me. Anyway, I thank you for watching, and I hope that you will be back for more soon. Bye for now. Puzzle solved.